Next we see the topic of atomic spectra. Spectra means colors. It will be observed by the when white light is examined through the spectrometer, we obtain the electromagnetic radiations of all the wavelengths, which is the continuous spectrum. Okay, we know the materials, that is a solid, liquid and gases. Electromagnetic radiation when they are heated and it emitted the radiation that is belongs to the continuous spectrum, that is belongs to the continuous spectrum. Previously in the century of 20th, so many scientists have spent more time to explain about the characteristics of the radiation that is emitted by the atoms of individual element by exposing the light or electrical discharge. Then if we see through the one spectrometer or it will be photographed, instead of the continuous spectrum we obtain radiation contains of certain discrete lines, each having the own characteristics wavelength. Okay, these spectra are unique to the each element and it is used to identify the element of the gas, and also these are vary from the one gas to another gas. So this uniqueness of line spectrum of elements made the scientists to determine the composition of stars, sun, and also it is used to identify the unknown compounds. Next, hydrogen spectrum. When the hydrogen gas is filled in the tube, it is heated up and emits electromagnetic radiation of certain sharply defined characteristics wavelength. It is called as a hydrogen spectrum, hydrogen emission spectrum, hydrogen emission spectrum. That means in the tube, hydrogen gas will be filled. It is heated. After heated up, it will emit the electromagnetic radiations of certain sharply defined characteristics wavelength. It is called as a hydrogen emission spectrum. Okay. Suppose when any gas is heated up by passing the thermal energy, the electrons will be excited. Like that, by passing the light on the atoms, electrons can be excited by absorbing the photons. Once the electrons gets a sufficient energy, as like a Bohr postulate, it absorbs the energy with a particular frequency or wavelength. It jump from the one stationary orbit to the higher energy state. Those wavelengths are for which colors are not observed, that will be seen as a dark lines in the absorption spectrum. Dark lines in the absorption spectrum. Here, since the electrons in the excited state have very small lifetime, these electrons jump back to the ground state through the spontaneous emission of radiation within the short duration of the time by emitting the radiation with the same wavelength that is correspond to the colors it observed. It is called as a emission spectroscopy. Emitted radiation contains both wavelength lesser and greater than the visible spectrum. That means emitted radiation having the both lesser and greater wavelength than the visible spectrum. Okay. In the spectral series of hydrogen atom, these lines of hydrogen are grouped in the separate series. Each series, the distance of the separation between the consecutive wavelength decreases from the higher wavelength to the lower wavelength, and also wavelength in each series approaches some limiting value. It is known as a series limit. It is known as the series limit. These series are named as the Lyman series, Polymer series, Poisson series, Bracket series and Fund series. Okay. Then we are going to derive the wavelength of these series lines. The wavelength of these spectral lines can be derived from the Bohr atom model of equation. That is 1 by lambda is equal to R into 1 by n square minus 1 by m square, that is equal to nu bar. Nu bar is nothing but a wave number. That means inverse of the wavelength. Inverse of the wavelength. Here R is known as the Rydberg constant. That value is 1.09737 into 10 to the power of 7 per meter. Per meter. Here n and m are the positive integers, and also that values are m is greater than the n. M is greater than the n. First we see the Lyman series. In the Lyman series, it is obtained by when electron is jumped from the any of the higher orbit to first orbit. So n and m values are n is equal to 1, m is equal to 2, 3, 4. So the wave number or wavelength of the spectral lines of Lyman series, it is obtained in the ultraviolet region, that is UV region. So nu bar is equal to 1 by lambda is equal to r into 1 by 1 square minus 1 by m square. Okay. Next, Polymer series. The Polymer series is obtained by when electron is jumped from any of the higher orbit to second orbit. So n value taken as the 2, m taken as the 3, 4 and 5 going on. Now the wave number or wavelength nu bar is equal to 1 by lambda is equal to r into 1 by 2 square minus 1 by m square. Next, it is obtained in the visible region. It is obtained in the visible region. Next, come to the Poisson series. The Poisson series is obtained by when electron is jumped from the any of the higher orbit to third orbit. So n takes a 3, m takes a 4, 5, 6. Now the wave number nu bar is equal to 1 by lambda is equal to r into 1 by 3 square minus 1 by m square. It is obtained in the infrared region. Next, Brocket series. It is obtained by when the electron is jumped from any of the higher orbit to fourth orbit. So n takes the 4, m takes the 5, 6, 7. So wave number nu bar is equal to 1 by lambda is equal to r into 1 by 4 square minus 1 by m square. This region is obtained in the, this series is obtained in the infrared region. That means middle of the infrared region. Middle of the infrared region, Poisson series obtained in the near the infrared region. Next, Fund series. It is obtained by when electron is jumped from any of the higher orbit to fifth orbit. So wave number nu bar is equal to 1 by lambda is equal to r into 1 by 5 square minus 1 by m square. This series is obtained in the far infrared region. Far infrared region. These are all about the spectral series of hydrogen atom. Spectral series of hydrogen atom. Next we see the limitation of Bohr atom model. It is having some drawbacks. Okay. Let us see the drawbacks of Bohr atom model. So the first one, the Bohr atom model is valid only for the hydrogen atom. That means like a hydrogen like atoms alone. It does not suitable for the complex atoms. Okay. Next one, the spectral series are, when see the closely, the individual lines of hydrogen spectrum is accompanied by the number of faint lines. These faint lines are called as the fine structure. Such a fine structure is not explained by the Bohr atom model. Okay. Third one, the Bohr atom model fails to explain about the intensity of variations in the spectral series. Intensity of variation in the spectral series. Fourth one, the Bohr atom model cannot completely explain about the distribution of electrons in the atom. Distribution of electrons in the atom. These are all about the limitation of Bohr atom model.